Okay, so in this episode, we're going to be continuing the topic of the electric motor, but in this video, it will be primarily focused to the commutator. Okay, so in the electric motor, the part of the commutator, the name of the commutator in the electric motor is called the split ring commutator. Okay, while in the generator we call it the slip ring commutator. Okay, so sorry, just give me 1 second. Yeah, okay, so the commutator over here is called a split ring commutator. We have studied in the previous video the idea of the commutator to understand the function of the commutator. The commutator is a copper it's a copper conductor, okay, that spins that spins and what it does is that it basically reverses the current every half spin to allow a full 360 rotation. A copper conductor that spins, okay, to reverse the current every half spin to allow a full 360-degree rotation. This is the commutator, okay? Now, how it exactly does this, we're going to understand that by studying in depth the structure of the commutator itself, okay? We're going to go deep into the commutator, okay? But let's just write a quick note over here, is that it solves half spin problem. Perfect. Now let's talk about the structure of the commutator, okay? Structure. The structure of the commutator, now as we have drew it, okay, we drew it as a cylinder with a line in between, okay? Actually, the commutator has an insulating material in between it. Why is that? Because when we study the generate motor, we say that there is brushes, okay, and current is passing through it. But if there is nothing in between the commutator, the current will just cycle between the brushes, power supply, brushes, power supply, brushes, power supply. It will never go to the coil. So the insulator in between prevents that from happening, okay? What I'm talking about is basically, let's do a rough drawing over here to explain my point. In this case, if I have the coil, this is my commutator, okay? Now my commutator is connected to brushes and a power supply. When the current is passing from the positive to the negative terminal, when the current reaches the commutator, it will just pass through, go back over here, go back over here, and it will just keep cycling over here, okay? Because the current is empty from between. Now, if I put insulation on the commutator, so now we have the coil again, okay? And in the commutator, I'm going to put some sort of insulation material, okay? And then I will connect the brushes power supply. In this case, the current will flow. Instead of passing through back to the power supply, it will take its path up to the coil, induce magnetism on the coil between the magnets to make a spin, come back from this side, enter this side to the negative terminal, cycle through positive to negative without passing through in between because there is an insulating material. So it will go like this, coil, come back. In this case, there is no insulating material. So because it is copper is a conductor of electricity, it will just conduct the electricity and let the current pass. Because we said it is a copper conductor, right? But over here, if we put an insulator which does not let electricity pass through, it will go from here back out and in. It will not pass the middle of the commutator, so it will let the current pass to the coil. Okay? And this is the idea of the commutator. the depth of the commutator. Now we're going to draw it in a detailed and nice diagram. So the structure of the commutator is something like this. First of all, we can say that we have it is an electrical conducting material, which we said is copper, Cu, with insulation in between. Okay, this is the idea. So what does this mean? This means that, so if we draw a nice commutator diagram over here, we can say that if there is a coil, commutator, brushes, and power supply. Instead of the current passing like this, positive and negative, instead of current passing like this, in which there is no current to coil, because there is no insulating material. Copper is a conductor of electricity. It will just take the current and make it pass by over here. Okay, and this is a problem, right? We do not want no current over here. This is a problem, right? So to solve this problem, we can say that it will pass like this. Like what? Like this. Same commutator, but with an insulating material. Now look what will happen. If I have the commutator over here, connected to brushes, power supply, but the only difference is that I will put some sort of insulating material in between the commutator. Okay, like this. Now because of this insulating material, what will happen to the current? The current will start from the positive terminal to the negative. It will come. It will pass this area like this, go up here to the coil, come back from the coil. When it comes in this area, it will come through this part, okay, to the brushes and back to the negative terminal, okay? Because the insulator is a non-conductor of electricity, so it will not let electricity pass through. It can go to the coil, make electromagnetic induction in the coil, put poles in the coil with the magnets, make a spin. We have talked about this in the previous video. And this is the idea of the commutator, okay? And why there is an insulating material in between the commutator, basically to prevent the current from not going to the coil. So this is what we call the insulation, okay? And this is current supplied, of course, okay? This is the idea of the commutator. Now we're going to just briefly talk about this and write some notes about this, so when revising you can easily read that. Sorry. Over here, let's talk some notes about this idea that we have just explained. Since insulator is present, okay, commutator cannot let cannot let pass current, cannot let current pass directly through it. Instead, what it's going to do, okay, instead it redirects the current to the coil. And when the current goes to the coil, what happens? There is some sort of magnetic induction where there's going to be north and south, right hand rule, magnets, and coil will spin. So to the coil, okay, and comes back to commutator for next cycle, okay, always from positive to negative terminal is the current, okay. And this is the idea of the commutator. Basically, about the commutator, we need to know that the commutator, it is a copper conductor that spins to reverse the direction of the current every half rotation. We reverse the direction of the current to reverse the magnetic poles on the current or carrying wire or the coil that was induced. When we reverse the magnetic poles induced on the coil, it will automatically make it a full spin, solving the problem of the half spin, which we discussed in the previous episode, okay? Now, in the commutator, deep depth into the commutator, we have an insulator in between. Why is there an insulator? Because when current is passing, it is a copper electrical conductor. If there is no insulator, current will pass through the conductor and it will just keep cycling over here. We don't want that. We want current to pass to the coil so it can produce magnetism and spin, okay? So in this case, we'll put an insulator in between. So the current will go from the positive terminal up here. It will not pass the insulator and it will be redirected to the coil, come from the other side of the coil back to the negative terminal and keep cycling, okay? So yeah, this is the idea of the structure of the commutator, and we have written the description over there. I'm not going to make a revision video or review summary video for this one because it's a small idea. In the next part, we're going to be defining some parts of the motor, and we're also going to be looking at how the commutator exactly works when it spins. Okay, so it's going to be interesting, and I'll see you in the next one.